Hi student, it is the nth root of unity lecture number 3. In this lecture I will discuss some extra properties of nth root of unity. Okay, so what we have taught in the previous section that the nth root of unity is nothing but the equation omega to the power n is equals to 1, which has the root like 1, omega 2 dot 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 omega n minus 1. Okay, and we have studied in the previous lectures, in the maybe second lecture, that the sum of the roots like 1 plus omega 1 plus omega 2 plus dot 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 omega n minus 1 is nothing but 0. Okay, we have studied these important properties in the second lecture. So we have deduced some others extra properties from this property, like if this property hold, okay, and it is obviously hold, then we can write omega in two part. The one is the real part, one is the imaginary part. Okay, so 1 plus real of omega 1 plus I of real imaginary of omega 1. Okay, that is the complex number representation of omega 1. Okay, similarly we can write that real of omega 2 plus I imaginary omega 2. Okay, so similarly we can write that dot 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 real of omega n minus 1 plus I of imaginary of omega n minus 1 is equals to 0. Okay, where I is nothing but root of minus 1. Okay, so what we can do now, we can combine this real part and imaginary part to separate out. So what is this? So 1 plus real of omega 1 plus real of omega 2 plus dot 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 real of omega n minus 1 and plus I imaginary of omega 1 plus imaginary of omega 2 plus dot 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 imaginary of omega n minus 1 is equals to 0. So this and this is also, we can write that like some capital omega 1 plus I capital omega 2 is equals to 0, where capital omega 1 is nothing but 1 plus real small omega 1 plus real of small omega 2 plus dot 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 real of small omega n minus 1, and capital omega 2 is nothing but imaginary of omega 1 plus imaginary of omega 2 plus dot 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 imaginary of omega n minus 1. Okay, and this complex number is 0. So if this complex number is 0, so this separately, the real part, that is the omega 1 is equals to 0 and omega 2 is equals to 0. That is the 1 plus real of omega 1 plus real of omega 2 plus dot 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 real of omega n minus 1 is equals to 0, and imaginary of omega 1 plus imaginary of omega 2 plus dot 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 imaginary of omega n minus 1 is equals to 0. Okay, so what is this actually? So, and if we write 1 is nothing but real of omega 0, you can say that, okay, and you can add imaginary of omega 0, and imaginary of omega 0 is nothing but 0. So in combine, okay, to combining we can write that summation of real part, okay, is equals to 0 and summation of imaginary part is equals to 0. And what is the real part and what is the imaginary part? And that is this one, that is the 1, and real parts are 1 omega 1 omega real of omega 1 real of omega 2 dot 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 real of omega n minus 1, and imaginary part are simply nothing but imaginary of omega 1 imaginary of omega 2 dot 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 imaginary of omega n minus 1. Okay, and their sum is 0. So we get two important properties deduced from this original one, that is the sum of the nth root of unities is equals to 1, and from that we can also get that the sum of real part and sum of imaginary part are also equals to 0, and we can do a true problem based on this property. like, okay, consider this question like summation of k is equals to 1 6 sine 2 pi k by 7 minus cos 2 pi k by 7. Okay, so what is this sine 2 pi k by 7? It is nothing but imaginary part of 7th root of unity, and cos 2 pi by k by 7 is nothing but real part of 7th root of unity. Okay, so if we split this, so we can get summation of k is equals to 1 to 6 sine 2 pi k by 7 and minus summation of k is equals to 1 to 6 cos of 2 pi k by 7. Okay, so what we can do is, here the term is 1 to 6, there are 6 term, and here also has 6 term, but it is a 7 root, so this should be 7 root must be there. So what we can do is that we can add k is equals to 0 here and also k is equals to 0 here. Okay, so it is nothing but k is equals to 0 is equals to 0, k to 0 to 6 sine 2 pi by k by 7, and so 0, so it is nothing but sine 0 is 0, so we can add nothing, like add minus 0 or plus, you can add 0, and that's nothing altered. But for cos part, okay, for k is equals to 0 to 6 cos 2 pi by k by 7, we must have minus 1 because cos 0 is equals to 1. Okay, so since this is nothing but sum of the imaginary part of the nth root, 7th root of unity, so it is 0, minus this also sum of the 7th root of unity, it is also 0 minus 1, so this gives 1. Okay, so answer is 1. Okay, up to this it is clear. Next, move to another two important properties, and which is also reduced from the properties which we studied in the before. Like, you know that and we also discussed in the previous section that omega to the power n minus 1 is equals to omega minus 1, omega minus omega 1, omega minus omega 2 dot 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 omega minus omega n minus 1. Okay, so now differentiate both side. Okay, and you know what is the differentiate between both side with respect to omega. So what we can you will get, it is nothing but n into omega to the power n minus 1 is equals to take this one and up to this, so omega 1 omega minus omega 2 dot 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 omega minus omega n minus 1, and for this differentiation it is the into 1, plus take this one omega minus omega 1 omega minus omega 2 dot 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 omega minus omega n minus 1, for this also it is the 1, so up to this it will be omega minus omega it is 1 omega minus omega 1 dot 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 omega minus omega n minus 2. Okay, for the last term. So now take this equation 1, then now divide, or take this equation 2, so now divide equation 2 by 1 both side. Okay, what you will get, so n into omega n minus 1 by omega n minus 1 is equals to, so you can simply that for this, for first term, like for omega 1 omega minus omega 2 dot omega minus omega n minus 1, and for this part is not so this part is not wrong, this will not be there. For this everyone is there for, but not omega minus 1, so it will be 1 by omega minus 1. For second part it will be plus 1 by omega minus omega 1 plus dot dot omega minus omega n minus 1. Okay, this is very clear, and these also very important properties for question. Okay, these also very good question or properties. Okay, now to another question and properties, like take omega minus omega 1 omega minus omega 2 dot dot omega minus omega n minus 1 is equals to omega n minus by omega minus 1. Okay, and you know what is this omega n minus 1 by omega minus 1? It is nothing but omega to the power n minus 1 plus omega to the power n minus 2 plus dot 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 1, and this the n terms. Okay, now take natural logarithm both side, and this will give you ln of omega minus omega 1 plus ln of omega minus omega 2 dot 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 ln of omega minus omega n minus 1 is equals to ln of omega to the power n minus 1 plus omega to the power n minus 2 plus dot 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 plus 1. Okay, so now differentiate both side with respect to omega. What we will get, that is the, for first term it is nothing but omega minus omega 1 into 1 plus 1 by omega minus omega 2 into 1 plus dot 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 1 by omega minus omega n minus 1 into 1 is equals to 1 by omega to the power n minus 1 plus omega to the power n minus 2 plus dot 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 plus 1. And for this term it is the n minus 1 into omega to the power n minus 2 plus dot dot dot, and take second term it will be n minus 2 omega to the power n minus 3 plus dot dot dot. Okay, something will be there. Okay, and or you can take this, the nothing but omega to the power n minus 1. Okay, 1. So and so the last term will be plus 1. Okay, so what you will get, that 1 by omega minus omega 1 plus 1 by omega minus omega 2 plus dot 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 1 by omega minus omega n minus 2. Okay, so and it is nothing but here it is also n terms. Okay, not n terms, for differentiation it is nothing but n minus 1 terms. Okay, now put omega is equals to 1, and that will give 1 by 1 minus omega 1 plus 1 by 1 minus omega 2 plus dot 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 1 by 1 minus omega n minus 1, and this will give you nothing but 1 to the power n minus 1, and it is also here it is n terms. Okay, and it will be here it is the n minus 1 terms, that is the n minus 1 into 1 plus n minus 2 into 1 up to 1, and here it is the n minus 1 terms. So what it will give, it will give 1 by n into sum of the n minus 1 term from 1, and here n is nothing but a natural number obviously, so it is nothing but n into n minus 1 by 2, so it is nothing but n cancel out, so it is nothing but n minus 1 by 2. So we get a beautiful result from the previous result, that is the 1 by 1 minus omega 1 plus 1 by 1 minus omega 2 plus dot 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 1 by 1 minus omega n minus 1 is equals to n minus 1 by 2. Okay, this is a very important and very beautiful result. Okay, and also the first and the second result for previously we get that n into omega to the power n minus 1 by omega to the power n minus 1 is equals to 1 by omega minus 1 plus 1 by omega minus omega 1 dot 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 1 by omega minus omega omega n minus 1. Okay, and the first one is that sum of real part of nth root is equals to 0, and sum of imaginary part of nth root is equals to 0. Okay, so today's lecture is up to that. Okay, if you like to share and subscribe. Thank you.